Hi everyone. So welcome to the course. If you haven't already watched the other video that goes over how the course works, I strongly suggest you watch that first. There's a link here. It's in the first announcement. I'll put it in the second announcement with this video as well. So in this video, what I want to do is let you know the updated times to come and get help. It's very difficult for us to explain this stuff by email. I also want to set expectations of what the quizzes are going to be like, the midterm and the final, because they are worth a significant portion of the grade, and they are going to require you to do the exact same things that you have to do to solve the labs. And then I want to go over an actual example of a quiz question, just so you know what to expect with that as well. So let's first discuss getting help. So lab discussion, get help. So there are lab discussion hours. This is going to be available to you with Jesse on Thursdays at 1 o'clock on Zoom. And here is a link here, and he can help with any labs that are basically due that week. And we strategically put it on Thursday so that, you still have some opportunity to hand things in late. You could still have some opportunity there. So the Wednesday lab you could hand in late, and the Thursday lab is due on Thursday. So that basically gives you an opportunity to ask for help on those labs. Also, every day there's a lab due, which is Monday, Wednesdays, and Thursdays. Sporthy, who's a graduate assistant, she's a PhD student, is going to be available on Mondays, Wednesdays, and Thursdays at 6 o'clock until 7 o'clock. That said, if somebody comes at 6:30 and they still need help until 7:15, she might be there till 7:15, but you get the general idea of that. Please come at 6:30 if you need help, and she'll be able to talk you through and walk you through any of these kinds of things. So as I mentioned before, it is super important that you actually know how to program into the Excel to do the data analysis, because if you don't know how to do that, the quiz is going to be impossible. So let's what I'm going to do is take an example of a quiz question, and then we'll go from there. All right, so here is an example quiz question. So it gives us an actual question and some information, and I'll read that in a second. And then it gives us a whole list of data, which effectively forces us to use Excel in order to solve this. And then you simply put your answer in the box. Now, you won't be able to see this. This tells you the answer down here. But basically, you're just going to put your answer here. This is the, instructor version. So basically how it works is the midterm will have 7 questions on it. They're worth 10 points apiece, and you can get a maximum of 50 points. So effectively, do 5 out of 7, but you can try all 7 if you want. If you get 2 wrong, you get a 50. If you get all 7 right, you still get a 50. But if you get 100, it doesn't matter. You still get an A in the class, right? If you get 100 on the midterm and the final and do all the labs, you definitely get an A. So it doesn't really matter if you don't get those bonus points. So that's basically how it works. It will be some data is given, and you literally type your answer into the box. So it's not multiple choice. You have to be able to analyze this data with Excel. So this is basically how it's going to work. It's incredibly important that you do the labs with the understanding that you're going to have to do them independently. If you need help, or you don't understand something, or your friend told you that you can just use this formula, then you need to make sure that you really understand why you use that formula, because when you get to the midterm and the final, you're going to have to make up the formulas yourself. Okay, so they're not the same as the labs. You can't just paste the data into the lab files, but they're very similar to the labs, just questions about similar concepts. So that's basically how it's going to work. All right, so all I've done so far is simply grab this data, hit copy, and then I pasted it over here into Excel. I did paste as text because I don't like it to change my font. So I've copied and pasted the data. So let's read the question. It says, a sports drink company is trying to duplicate a competitor's beverage. They have already generated a calibration curve of conductivity versus electrolyte concentration. The equation of the line of best fit for the calibration curve is y equals 8,427x plus 1,066.3. Given the conductivities of the 20 samples of the competitor's sports drink below, find the relative standard deviation, RSD, in parts per thousand of the concentration of the electrolyte in the drink samples. Report the answer to 1 decimal place. Now, note, if you haven't done this before, this is completely not doable, right? But after you've done the first 5 labs, you'll have done similar things to this multiple times, so it'll be less unfamiliar, right? Right now, this might be super unfamiliar. All right, so basically what we need to realize is that what we're given here are a bunch of conductivities. Okay, so we measured the conductivities of these samples, but we don't care about the conductivity of the sports drink. What we care about is the concentration of the electrolyte so that we can copy their sports drink and sell our own that tastes better. Okay, so that's basically what we're trying to do here. So calibration curves are to take easy to measure data, conductivity, you literally just stick a probe in there and read the number, to difficult to measure things, but things we want to know, the concentration of electrolyte in there, the common electrolyte here is sodium chloride, in an actual sports drink like Gatorade or the million other brands of such things. So this is basically what we need to do. So we need to convert these Y values into X values. Specifically, we need to convert these conductivities into concentrations. So how are we going to do that? Well, what we're going to do is we're going to use the equation of the line. This is why we want to solve for x. So first, what we need to do is we need to take the y value and subtract from both sides b, the y-intercept. So basically, we're going to subtract from each of these 1066.3. All right. Then what we're going to do after we do that is divide by the slope. So basically we move this over here by subtracting and then divide by the slope. Note that this has to be in parentheses because we want to subtract first and then divide. Don't forget your PEMDAS, your order of operations, and it will divide first and then subtract, and then you'll get the wrong answer. But in this case, we want to divide by the 8427. So we do that. Now these are concentrations of electrolyte, presumably in molar, all right, which would not be a common unit for sports drink companies, but it is a common unit for chemists. Now I want to do this for all 20, so I simply drag down. Note that it drags down to A4, and it drives down to A9, and it drags down to A16, so on and so forth. So we drag through. These are now all of the individual concentrations. You could theoretically do this by hand, but it would take a long time. But now it asks me to calculate the RSD, and if you haven't done that before, the RSD, the relative standard deviation, is the average, the standard deviation divided by the average times 1,000. So the first thing we need to calculate is the average. Then we need to calculate the standard deviation. I'm going to abbreviate that, standard deviation. And then we can calculate the RSD in parts per thousand. So to calculate the average equals average. Open a parenthesis. Simply select our data like so. This is the average of these values. The standard deviation, very similar, except the function is called STDEV. V, not X. All right, open a parentheses, select your data. Be sure not to select the average. You only want to take the standard deviation of your data, not including the average. And we can calculate the standard deviation. Now, by definition, the relative standard deviation in parts per thousand is the standard deviation divided by the average times 1,000. Okay, and when we do that, we get 28.96623. So now what we do is we want to report our answer to one decimal place. So we'd go down here and we'd type in 29.0. You'll notice that this was a little bit different before earlier in the video because there was a little bit of a mistake, but this is 29.0. Okay, so this gives us the answer. Look, could you calculate each of these individually 20 times? Yeah, it's a pain in the neck, but it's not impossible, right? You're just multiplying and dividing. Could you easily calculate the average of these? Sure, just add them all up and divide by 20. Pain in the neck, but not impossible. Could you calculate the standard deviation of all of these manually? No. I'm going to go with no. So basically, I don't think it's possible to calculate the standard deviation of these manually and not make a mistake. Is it truly impossible? No. Would it take an experienced person who wasn't going to make a mistake 10 or 15 minutes? Yeah. So you don't want to have to do that. So you got to learn how to use Excel to do these things. Okay. And then the RSD you can calculate, but you have to have the standard deviation in order to calculate the RSD. This could easily be calculated on a calculator, but again, you have to calculate the standard deviation, which could not easily be calculated. So please use the labs in order to learn how to do these things. Make sure you know how to do them. Once you know how to do them, the midterm and the final are going to be easy. But if you're taking formulas from videos or you're taking formulas from other people, it's not going to work. Okay? So it's really important that you use this opportunity to learn how to do the things. We're here to help. Sporty has office hours, Jesse has office hours, and we are very happy to help as well. All right? So please use us for that. All right, so I punched this into a chatbot and AI and basically allowed it to, or just wanted to see what would happen. So first thing it does is it tells us to convert these. So this is exactly what we just did. We took the y value, which was given, we subtracted the b value, which is the y-intercept, and then we divided by the slope. It then, in the second iteration, basically did that for each of the trials as shown here. Then it found the average of these, simply added them all up and divided by the 20 samples. Okay, so it just found the average. It then calculated the standard deviation by looking at the individual deviations from the mean and squaring them and adding them all up and dividing by n minus 1, which is exactly what we should do. All right, so it did this all correctly. It then found the RSD correctly by taking the standard deviation here, dividing by the mean here, and multiplying by 1,000. And it got it wrong. Okay, so it did everything correctly. It even put the answer in a box, which is comically funny because it says round your answer to one significant figure in the box. Remember that the answer is 29, not 26.7. This looks like it's doing everything correctly, and it's not. I don't know exactly why it's not. I haven't looked into it in super great detail, but it doesn't do it correctly. So I strongly recommend that you're not using AI to try to solve these problems. If this helps you, punching this into AI helps you to figure out how to solve it, by all means, use it. But if you're looking for answers, this doesn't have any useful answers. Okay, and we've checked all the questions against the AI, and we haven't found a pattern of it being able to answer correctly. So please don't look to AI for the answers to this. Please use the labs as an opportunity to learn how to do these things, and then the midterm and the final as an opportunity to show that you've mastered these concepts. Data analysis is something that is extremely important in the scientific modern world. It's something that real scientists, many real scientists do on a daily basis, and it's a useful thing to know. We're here to help you. We look forward to working with you and helping you to understand more about how to do these things. Thanks for choosing this course this summer, and we'll get started next week. Thank you.